With all the attention we pay to high-tech automotive components these days, it's easy to overlook the importance of a vehicle's bumper. About 80% of car accidents are front or rear collisions. The bumper is designed to hit the other car's bumper and absorb the force of the impact, minimizing damage in low-speed collisions. Bumpers can be made of plastic, fiberglass, aluminium or steel. This company makes steel bumpers. They start out as blanks, steel sheets just 2 millimeters thick. These ones are en route to becoming truck bumpers. A robot feeds each blank through a series of dies, 7 to 9 of them, depending on the bumper model. Each die stamps the blank to a particular shape using 2,000 tons of force. This progressively forms the blank into the final bumper shape. Both the front and rear bumpers go through the same process, only the dies are different. The bumpers now travel to the next production area, where a worker clamps each one onto a specially designed cart. At this point, the factory paints certain models. These bumpers, however, will get a chrome plating. First, they travel through a series of buffing wheels. The bumper surface must be impeccably smooth because the chrome finish magnifies even the most minuscule flaw. A computer-guided crane stacks the bumpers and maneuvers them through the chrome plating process. It first submerges the bumpers in several cleaning tanks to remove any residue that previous operations might have left on the surface. The chemicals used are a closely guarded secret. The first plating tank applies a coat of nickel to protect the steel from corrosion. The next tank applies the chrome layer. The factory uses the standard electroplating process. In the water and chemical-filled tank, it laces particles of the plating metal with a positive charge and runs a negative charge through the bumpers. This magnetically draws the particles onto the bumpers in an even layer. After a thorough rinse, the bumpers enter the inspection area. Workers scrutinize the chrome mirror finish under high-intensity light. Meanwhile, this machine pressure injects molten plastic into various molds. The machine's built-in cooling system hardens the plastic within seconds. Then out come the plastic components that attach to the bumpers. One of those plastic parts is the step pad that covers the top of the rear bumper. Once the pad's in place, a worker attaches a tow bar and steel mounting brackets that also structurally reinforce the bumper. The front bumper goes down a different assembly line. A worker attaches a plastic trim that hangs down just below the bumper. Its aerodynamic shape helps direct airflow to the engine compartment. 4 steel reinforcing brackets attach the bumper to the truck's frame. Finally, the last components, the number plate holder and fog lamps. Workers tighten all the bolts to a specified torque. This ensures that the bumper and its mounting brackets will adequately absorb the force of a collision. Whenever a new model goes into production, the first few bumpers off the line go through a battery of tests to ensure they can withstand stress, vibration, and a certain degree of what engineers call crash energy. Other types of bumper systems use a combination of springs and energy-absorbing material, such as plastic foam. With either method, the goal is for the bumper to absorb the impact. In a low-impact crash, this should ideally confine the damage to the bumper itself, leaving the headlights and engine unscathed. Smashing!
slow up, no I don't take shit, I got no love